Okay, so we'll just go back in time. We have our circle with a radius of a, and the cross sections perpendicular to our x-axis are squares. And so like I said a minute ago, the area is the side length squared. The side length is 2y because the height of this from the x-axis to the function is y, and this is symmetric, so it must be y down there. Side is 2y, area is 4y squared, so we'll integrate from negative a to a, 4y squared, but it has to be done in terms of x, so we have to figure out what y is in terms of x. And so since this is a circle, and we've drawn it centered at the origin because that just makes things easy, it has a radius of a, so x squared plus y squared equals a squared, so y squared is a squared minus x squared. So we've got 4, and then y squared is a squared minus x squared dx. And this should be our setup. If you want to make your life a little bit easier, you can note that from negative a to 0 is the exact same as 0 to a. So I could double this and just do 0 to a. Don't have to do that, but that will make the arithmetic easier. And then we just integrate 8. And then we've got the integral of a squared with respect to x is a squared x minus x cubed over 3 from 0 to a, or 8 times a cubed minus a cubed over 3. And that ought to be 2a cubed over 3 times the 8, which is 16a cubed over 3. Good or no? Any questions there on 25?
So when it says perpendicular to a diameter, it means the x-axis?
Well, it says perpendicular to a diameter, so you can pick any diameter you want. So I picked the x-axis. Could have picked the y-axis. Could have picked this axis or this diameter, but that diameter would really suck to do because we don't know how to do it unless it's the x or the y-axis. You could have done it in terms of, basically they're saying do it in terms of x or do it in terms of y. Either way, it comes out to be the same because it's a circle. Does that answer your question?
Yeah.
Wonderful. All right. Next one, I believe, is 50. Yeah. All right, number 50. I should probably find number 50 here. There we go. All right, number 50. We are asked to take 3x minus x squared. Looks like this. And y equals x, and take the region between those and revolve it around the x-axis. And so if we're going to take that region and revolve it around the x-axis, the first thing we need to do is figure out our limits of integration. So when does x equal 3x minus x squared? That'd be when x squared minus 2x equals 0, or when x equals 0, x equals 2. Everybody good with that part of it to figure out the limits of integration? Okay, and so this will be pi times the integral from 0 to 2 of the outer radius squared. And our outer radius is just the upper function, which is 3x minus x squared minus our inner radius, which is just x. So x squared dx, which looks to be answer choice pi 0 to 2. Looks like that's choice C. Any questions there on that? All right. Next one is 54. All right. So for 54, we got two curves, f of x and g of x, that intersect at a and b, and f of x is greater than g of x, and they're both positive for all x on the interval. Okay. So they don't give us actual functions. So let's just, there's f of x, there's g of x. They're both greater than 0. Here's a, here's b, both greater than 0, and f greater than g on the entire interval. We want to find the volume obtained when the region bounded by the curves is rotated about the x-axis. So we're just taking this and rotating it around the x-axis. d pi, integral from a to b of the outer radius, f of x, squared minus the inner radius, g of x, squared dx. And that's just our basic formula for just your basic formula. And looks like that's choice D. Good. Any questions there on 54?
It's the same thing if they put an absolute value sign, like absolute 0, an absolute value sign, right? That doesn't make a difference.
Yeah, that would not make a difference. There is, I mean, there aren't any. Those are brackets.
Oh, I think I was thinking of another question, but thank you.
Yeah, I mean, it wouldn't matter if you took an absolute value on those, just because f is always positive and g is always positive. So, yeah, I mean, they do kind of, yeah, I mean, the person that asked for it also just commented that they thought they were absolute value signs. Yeah, I mean, they do, from a little further away, they do sort of look the little ticks on the brackets at the top and bottom are kind of small. So, yeah, those are brackets, not absolute value. All right, let's see, where are we at? We did 54. Next one is number 5. Okay. All right, number 5, we got the curve y equals 4 over x squared plus 4, which I'm going to sketch. There we go, that's more accurate, except that it shouldn't really be ticking up at the ends there. This should just be symmetric and whatever, going towards 0 as you go towards positive, negative, infinity. If you don't know what it looks like, it's not a big deal. You can totally do the problem without knowing what it looks like, just by knowing that clearly it's always above the x-axis, because the numerator 4 is always above the x-axis, is always positive, and x squared plus 4 is always positive. And if the numerator and the denominator are both always positive, it's always positive. So it's always above the x-axis. So really all we're trying to do here is integrate from -2 to 2 of 4 over x squared plus 4 dx. And you might or might not recognize that this is an even function, and you could just do 0 to 2 because they're symmetric across the y-axis. But if you don't realize that, that's fine. And we did a couple integrals like this one when we were working through, I don't remember if it was the definite, it's probably in the definite and in the indefinite integrals, multiple choice, where it looked like an inverse tangent, but we had to get this to become an x squared or a u squared plus 1 down here. So -2 to 2, we got the 4 up here, and if we take a 4 out of the denominator, that makes that x squared over 4 plus 1. And I can then cancel those 4s, and we could rewrite this as an integral from -2 to 2 of dx over x over 2 squared plus 1. And if you do your u sub, u equals x over 2, then du is a half dx. Put your half, put a 2 in to cancel out the 1/2. And you've got 2 times the integral of du over u squared plus 1. And since u was x over 2, that becomes -1 and 1 instead of -2 and 2 when you take half of each of them. And now this just becomes 2 inverse tangent u from -1 to 1. And the inverse tangent 1, 2 times inverse tangent 1 minus inverse tangent. -1, inverse tangent of 1 is pi over 4. And inverse tangent of -1 is -pi over 4. So pi over 4 plus pi over 4 is pi over 2 times 2 is pi. Good or no? Any questions there on number 5? All right, next one is number 7. Number 7, we're looking for the area between 2 over x, which is looks something like that. At least that's the first quadrant part of 2 over x. And then x plus y equals 3. X plus y equals 3 is the same as y equals -x plus 3. I have not drawn this well. Should be more like this. -x plus 3 is going to be more like that, coming across the top of it. So we got 2 over x, and we got y equals -x plus 3. So we're looking for the area between those. So we got to find the limits of integration. Limits of integration can be found by just setting 2 over x equal to -x plus 3. We multiply by the x, we get 2 equals -x squared plus 3x. Or x squared minus 3x plus 2 equals 0. And we would see that this theoretically intersects at x equals 2 and x equals 1. And if you plug those both in, you'll see that that is true. If I plug in 1, I get 2 and 2. If I plug in 2, I get 1 and 1. So it now just needs to be an integral from 1 to 2 of -x plus 3 minus 2 over x dx. And as you integrate that, it's saying so, that's just more questions. Okay. As you integrate that, you end up with -x squared over 2 plus 3x minus 2 ln absolute value of x, all from 1 to 2. At 2, that's 2 plus 6 minus 2 ln 2, and then minus 1/2 plus 3 minus 2 ln 1, which is natural log of 1 is 0, so just minus 0. And let's see, 2 plus 6 is 8. 8 minus 3 is 5. Minus 1/2 ought to be 9/2. 9/2 minus 2 ln 2. And that doesn't look like an answer choice, does it? Did I?
The negative.
What?
Or the integral, like, I think you lost the negative when you integrated it.
Did I? Oh, I did. No. Oh, I lost this negative. Oh, yeah. That'll change that. Okay. Thank you. I was going to say, that doesn't look right. All right. -2 plus 6 is 4. Minus 3 is 1. Plus 1/2 is 3/2 minus 2 ln 2. Does that look more like an answer choice? It looks better. 3/2 minus 2 ln 2. Remember that this 2 is a coefficient on the natural log, can be brought in as a power. So we could write that as 3/2 minus ln 4, which does look like an answer choice. Choice E, which is hopefully what they said it should be. Lost that negative when I integrated. Thank you. Any other questions there on 7? All right, next one, number 8. This one last period, and this is, I mean, it's pretty easy if you recognize that the people that made this book are stupid. Says in the first quadrant, bounded below by the x-axis and above by the curves sine x and cosine x. Well, you know, you're going to have an infinite number of these regions as you go through here. But they are just talking about the first one here. So they intersect at pi over 4. And so they're just talking about this singular region here, even though you end up with another one of those down here and another one down here, and so on. And so in order to do this one, we have to take a look at the intersection point of pi over 4 and integrate from 0 to pi over 4 of just sine x, and then add to that the integral from pi over 4 to this point, which is pi over 2, where cosine is equal to 0 of just cosine. And then integral of sine is negative cosine. And then integral of cosine is just sine. And cosine of pi over 4 is root 2 over 2. Cosine of 0 is 1. And then sine of pi over 2 is 1. And sine of pi over 4 is root 2 over 2. And let's see, got negative root 2 over 2 minus root 2 over 2, which is a negative 2 root 2 over 2, or a negative root 2. And then you got a positive 1 plus another 1 is a 2. So you have 2 minus root 2. Any questions there on number 8? All right. Next one is number 10. Number 10 says we got y equals cotangent x, which should look like that. And the line x equals pi over 4 should be like that, and the x-axis. So x-axis, x equals pi over 4, cotangent x. And we're just looking for the area of that, so we need to figure out when does cotangent equal 0. Well, cotangent equals 0 at pi over 2. So this is just an integral from pi over 4 to pi over 2 of cotangent x dx. Everybody good with that setup or no? Hopefully. Okay, so then from there, integrating cotangent x. I told you guys, we did this one way back when, but I was like, you can memorize it or you can just remember that it's a u sub. Right? Cotangent is cosine over sine. So if you let u equal sine, du is cosine. And so this just becomes du over u, or natural log absolute value of sine. The natural log absolute value is sine x from pi over 4 to pi over 2. Plug in your pi over 2, sine of pi over 2 is 1, so you got natural log of 1, and then minus natural log of root 2 over 2. Natural log of 1 is 0, so you got negative ln root 2 over 2, which is not an answer choice, so you got to use some log rules. Negative ln root 2 over 2 is the same as ln of root 2 over 2 to the negative 1, which would be the same as ln of 2 over root 2, which is still not an answer choice, right? Negative exponent means you just flip it. But 2 over root 2 is the same as root 2, either by 2 equals 2 over root 2 could be written as root 2 times root 2 over root 2. cancel them. Or 2 to the first over 2 to the 1/2 is 2 to the 1/2, root 2. So this is natural log of 2 to the 1/2, which is the same as 1/2 natural log of 2, which is finally an answer to it. Good or no?
Makes sense.
Wonderful. What was that? That was 10, right? All right, next one someone has asked for is 13. So for 13, we are looking at the total area bounded. No, that's 12. The area bounded by y equals e to the x, y equals 2, and the y-axis. So here's y equals e to the x. Here's y equals 2. And the y-axis. So we're looking for that region right there. So that ought to be the integral of 2 minus e to the x, 2 minus e to the x, upper function minus lower function, integrated from 0, x equals 0, to whatever the x value is here. So if we want the intersection of those, we say e to the x equals 2, which would tell us that x equals the natural log of 2. Everybody okay there with that setup? Hopefully. Okay. And integral of 2 is 2x. 2x and the integral of e to the x is e to the x. So 2x minus e to the x from 0 to ln 2. We get 2 ln 2 minus e to the ln 2 minus 0 minus e to the 0. So we got 2 ln 2, e to the ln 2 is 2, so 2 ln 2 minus 2, minus a negative e to the 0. E to the 0 is 1, so minus negative 1, so plus 1. So it looks like we have 2 ln 2 minus 1, which appears to be choice D. Everyone good with that? Any questions on that one?
Could you do it in terms of y too, or do we have to do it in terms of x?
No, you could do that in terms of y. If you were to do that in terms of y, you'd have to figure out what this point is, which e to the x crosses through the y-axis at y equals 1. Right, it's y equals 1. When x is 0, right, y is 1. So you'd integrate from 1 to 2, and then, well, actually, no, you wouldn't be able to, because this is y equals e to the x. I mean, you could, y equals e to the x, and so that's x equals ln y. So you'd be integrating natural log of y dy, which we didn't learn how to integrate that because that's requires something called integration by parts, and you don't know how to do integration by parts because you learned integration by parts in Calc 2. But theoretically, yeah, the integral from 1 to 2 of ln y dy, integral of ln y is it's y ln y minus y. And so just for the fun of it, you'd get 2 ln 2 minus 2 minus ln 1 minus 1, which you'd see is still 2 ln 2 minus 2 plus 1. So 2 ln 2 minus 1 comes out the same. But you don't know that integral, so that's a BC thing. So no, you couldn't have done it in terms of y until next time you took a calculus class. Let's see here. Everybody good there with 13 now? All right, 16 is the next one. we are looking for the area enclosed by the curve y squared equals x times 1 minus x. So a couple of things about this one. First off, you should know what this is. You should know that this is a circle, hopefully. Right, if you rewrite this, y squared equals x minus x squared, or x squared plus y squared equals x, you should know that's a form of a circle. It'd be good to know what that circle looked like to help you with this, maybe. X squared minus x plus y squared equals 0. Or, yeah, I'm sure you guys learned how to complete the square to put the circle into standard form, right? X squared minus x. So complete the square on x squared minus x would be adding a fourth to both sides. And you end up with x minus a half squared plus y squared equals a fourth. In fact, we'll write a fourth as a half squared just because people like to see this is x squared, x minus a squared plus y minus b squared equals r squared. So you know that this is a circle that's centered at the point 1/2 comma 0 that has a radius of 1/2. So you're looking for that area. If you wanted to find an exact value of it, you could just find the area of a circle that has a radius of a half, right? Which would be pi times 1/2 squared. So it should be pi over 4 units. But since that's not an answer choice, we just got to go in and think about A, B, or C there and say, well, if we're looking for the area, it should be the integral from 0 to 1 of whatever y is. Well, y is the square root of x times 1 minus x dx. And that ought to give you the area of half of it. And then if you want the whole thing, right, if you want to get the other portion of it, you gotta just double that integral, which looks like choice B. Good or no?
Good, thank you.
Sure. Let's see, next one is 17. All right, 17 says we got y equals x cubed. We got some line here. And we've got this shaded portion. Oh, it's really poorly shaded. We got the shaded portion here. Plus we've got the area of this rectangle. And we want to know what's the ratio of the area of the rectangle to the shaded part above the cubic. So we're looking for the ratio of the blue to the just red. We know this is y equals x cubed. And we've called this point here c comma 0, which would make this point up here c comma c cubed, which would make this height c cubed, and which would make this length c, which would tell us the area of the blue region. So we're looking at a ratio between c to the 4th to the area of the red region, which is the upper limit, or the upper function c cubed, minus the lower function x cubed, integrated from 0 to c. So we've now got c to the 4th is the left part of our ratio to, well, the integral of c cubed with respect to x is just c cubed times x, right? C cubed is a constant. And then minus x to the 4th over 4. We'll evaluate that from 0 to c. So now we've got c to the 4th to c to the 4th minus c to the 4th over 4 minus 0. And now we've got c to the 4th to, well, this is 3c to the 4th over 4. Or if we cancel out the c to the 4th, it's 1 to 3/4, which would be the same as a ratio of 4 to 3. Good, makes sense? Any questions there on 17? All right. Next one is number 11. Number 11, we got the curve y equals x cubed minus 2x squared minus 3x in the x-axis. So we're going to have to figure out when does this thing intersect the x-axis. So let's figure out when that equals 0. So we'll factor out the x squared minus 2x minus 3. So we got x times x minus 3 times x plus 1. So this intersects the x-axis at 0, 3, and negative 1. It starts as a positive x cubed, so I know it's going to go up, down, up. Doesn't really matter how far up and down it goes. We know this is negative 1. We know this is 0. We know this is 3. Anything above the x-axis is a positive area, so we'll do integral negative 1 to 0 of x cubed minus 2x squared minus 3x dx. And then this one should come out to be negative. So we have to take the opposite of it. So instead of adding the integrals together, we'll subtract the second integral, the integral from 0 to 3 of x cubed minus 2x squared minus 3x dx. And then we'll just integrate. So we got x to the 4th over 4 minus 2/3 x cubed minus 3/2 x squared, negative 1 to 0, minus same thing, x to the 4th over 4 minus 2/3 x cubed minus 3/2 x squared, this time from 0 to 3. And the zeros are just zeros. And then the negative 1, when I plug that in, we're in the room here, plug in the negative 1, I ought to get 1/4 plus 2/3 minus 3/2. And then I'm going to subtract this evaluated at 3, which ought to be 81/4 minus, what is it, 54/3 minus 27/2. Oh, my handwriting is wonderful. Yeah, 54/3. I don't know why. I mean, that's 27. So let's see here. We got a 4th plus 2/3. We got a 4th minus 81/4, which ought to be negative 80/4, which is negative 20. We got a 2/3, and we've got a plus 54/3. So we'll call that plus 56/3. We got a negative 3/2 plus a 27/2. Is that right? Yeah. So negative 3 plus your 27 ought to give you plus 24/2. So looks like we got negative 20 plus 12, negative 8 plus 56/3. That's negative 24/3 plus 56 ought to be, gosh, I hope the answer is 32/3, because that was a lot of arithmetic for it not to be. Let's see, what did they say? 11. Ah, man, I did my arithmetic wrong, huh? Darn. All right, let's go back and look at my arithmetic. 0, 0, 0, 1/4 plus 2/3 minus 3/2 minus 81/4 minus 54/3 minus 27 halves. So that was right. Let's see. A fourth minus 81/4 is negative 80 over 4. That's negative 20. 2/3 plus 54/3 is 56/3. Negative 3 halves plus 27 halves ought to be 24 halves. All right, I don't see where my arithmetic went wrong. So somebody see where I made a mistake? Because it seems to think the answer to 11 is D. Oh, I know where I made a mistake. These are all supposed to be negatives, because this is 0 minus all of this. Everybody see that? That's bad by me. And you go through here and do this. This is 0 plugged in, so 0 minus -1 plugged in. So it's got to be a negative in front of this also now. We got negative 1/4 minus 81/4 is negative 82/4. We got negative 2/3 plus the 54/3 is now positive 52/3. And then positive 3 halves plus another 27 halves is plus 30 halves. So this is negative 41 over 2 plus 30 over 2 is a negative 11 over 2 plus 52 over 3, which is negative 33 plus 104 over 6, which should be 71/6, which is choice D. Oh, good. We did our arithmetic right now. All right. Sorry, I bungled that a bit. Everybody good with that? Any questions there on that one? All right, next one, 16. We already did. 17, we already did. All right, next one, 26. All right, 26. The base of a solid is the region bounded by the parabola x squared equals 8y, which is just 1/8 x squared. So it's a very shallow looking parabola. And y equals 4. So this is, what did they call this? They called it x squared equals 8y. And y equals 4. Cross sections perpendicular to the y-axis are equilateral triangles. I know these don't quite look the same, but they are, right? This is parabola symmetric across the y-axis. So this is x and x. So the side length is 2x. And the area ought to be the side squared times √3/4, just the basic formula for the area of an equilateral triangle. So this ought to be 2x squared √3/4, which ought to be x squared √3. And since these are perpendicular to the y-axis, we have to do it all in terms of y. So if it's got to be done in terms of y, I've got to replace x squared with 8y. So we end up with 8y √3 is the area of each of those equilateral triangles. And so we'll then integrate that from the lowest y value to the highest y value. So 8√3 times y squared over 2 from 0 to 4. Or 8√3 times 8 minus 0. Any questions there on 26? No, everyone's good. All right. Next one. 48. All right, let's see here. 48. Okay. 48 says we've got y equals x squared. And we got y equals 4. And what are we doing with that? We are revolving that around the line y equals -1. And so this ought to be pi times the integral from wherever these intersect. So y equals x squared and y equals 4. Well, those are intersected, x equals positive or -2. Once again, you can do -2 to 2, or you can do 0 to 2 and double it, but I'll just do -2 to 2 here. Our outer radius ought to be 1 plus 4. So our outer radius is 5 squared. Then our inner radius is 1 plus the value of x squared dx. And so that's our basic setup. That's all they've got for us is just the setup. So perfect. So whatever this comes out to be, pi times the integral from -2 to 2 of, let's see, 25 minus 1 plus 2x squared plus x to the 4th. So pi, -2 to 2, 24 plus 2x squared plus x to the 4th. Which, of course, is not one of their answer choices. Perfect. Let's see here. I wonder if they tried to do this. No, they didn't try and do it with shells.
Wouldn't it be negative?
Oh, those should be, yeah, those should be negative. Why didn't I distribute my minus sign? Gosh, I'm on a rough one here. That must be an answer choice. Is that an answer choice?
You do like 2 pi and then half of the interval.
Yeah, so that's what I was saying at the beginning, is we could do half the interval. Gosh, I don't know why I didn't distribute my minus sign. That's just atrocious. Anyway, like I said at the beginning, since this is symmetric across the y-axis, you can just do 0 to 2 and then double the integral. There we go. Gosh, yeah, distribute your negative sign, or else I'll chastise you for it like I am chastising myself for that horrific mistake. Ugh. Any questions there on 48? Everybody okay with 48? And then the next person's question is related to when do you know when to use 2 pi with half the interval, like number 48. Oh, like this one. Yeah, so I don't know, did that answer your question? Anytime it's symmetric across the y-axis, you can just have the inner, just do 0 to one side and then just multiply it by 2. Does that make sense to everybody about why we can go from pi -2 to 2 to 2 pi 0 to 2? I know, Alicia, you specifically were asking about that in number 48. Is that good? You can do that anytime the function is symmetric across the y-axis that you're looking for the area or the volume. You can just do that. Okay, I'm going to assume that answers that question. Okay, so next one we've got is number 10, which I think we might have already done. Yeah, we did 10. Then 16, which we already did. 17, which we already did. Okay, 53. 53 we have not done yet. Hold on one second. I gotta answer my kid's question. All right, sorry about that. So number 53 is the next one somebody asked about. 53 says we've got a sphere of radius r that is divided into two parts by a plane that is at a distance h, where h is between 0 and r from the center. So I'm just gonna, here's my three-dimensional sphere. I'm dividing it. I'm dividing it here by this plane. This is the line x equals h. This is my radius here. So this is the point r comma 0. Effectively, what I'm doing is I am taking this and rotating that region around the x-axis. So if I were to do that, I would need to have the equation of this circle that I'm rotating, or the semicircle that I'm rotating around. And a circle has an equation of x squared plus y squared equals r squared. So y should be equal to the square root of r squared minus x squared. And so this should be an integral from h to r, should be pi times the radius, which is the y value, squared. So r squared minus x squared dx. And did they just leave it like that, or do we got to evaluate it? So does that make sense? That setup makes sense to everybody? Okay, so when we evaluate, integral of r squared, which is just a constant with respect to x, is r squared x, minus x squared is integral is x cubed over 3. Plug in the h and the r and subtract. So we got pi times r cubed minus r cubed over 3 minus r squared h minus h cubed over 3. So I'll leave the pi out in front, and then we'll just sort of see what we end up with here. R cubed minus r cubed over 3 is 2/3 r cubed. And then minus r squared h, and then minus h cubed over 3. Is that one of the answer choices? No, it's not. So let's see if we distribute the pi through. There's one that's definitely not the one with the pi distributed through it. So we got to factor out the 1/3. So if we factor out the 1/3 from all of this, this will end up becoming pi over 3 times 2r cubed minus 3r squared h minus h cubed, which hopefully that's an answer choice. Oh gosh, I didn't distribute my negative sign again. Plus, and that's a plus. But that's an answer choice. 2r cubed minus 3r squared h plus h cubed. Choice looks like choice A there. Any questions there on that one? Okay. All right, next question was number 6. So for number 6, what are we asking here? On the page. It's going to be hard to do this if I'm not on the right page. All right, number 6 says parabola is x equals y squared minus 5y and x equals 3y minus y squared. And we're looking for the region between those two. So we got to first off, x equals, let's see, y squared minus 5y ought to look something like that. And then x equals 3y minus y squared ought to look something like that. Something like that. They both should intersect there at the origin. If we're looking for the region between them, we just need to figure out, first off, we know they intersect at the origin because they both have a y and an x-intercept of 0. But we also need to figure out the other place at which they intersect. And we'll write that this one was 3y minus y squared, and this one was y squared minus 5y. So 3y minus y squared needs to equal y squared minus 5y. Those ought to intersect at whenever 2y squared minus 8y is equal to 0. And like we just said a second ago, one of those times is at y equals 0, and the other is at y equals 4. And since everything is written in terms of y, and one function is clearly always to the right of the other one for all y values in that region, we will just go ahead and integrate in terms of y. The rightmost function, 3y minus y squared, minus the leftmost function, y squared minus 5y, dy from the lower limit of 0 to the upper limit of 4. And then we can simplify this down before we integrate here. 3y minus the negative 5y is 8y, and then minus 2y squared. So that ends up being 4y squared minus 2/3 y cubed, 0 to 4. The 0 is going to go away. This should become 64 minus 128 thirds, and 64 minus 128 thirds ought to be 64 thirds. So looks like that should be choice C. Any questions there on number 6? All right, just a couple more here. Number 9. So number 9, we got bounded above by sine x and bounded below by cosine x. From pi over 4, so right here, to 5 pi over 4, and 5 pi over 4 would be over here where they intersect again. Everybody good with that? So we're looking for this area of this region right here. And above, we are bounded by sine x. Below, we are bounded by cosine x. So sine x minus cosine x dx. Just integrated from pi over 4 to 5 pi over 4. Doesn't matter that sometimes we're below the x-axis over here because we're doing upper function minus lower function, which takes care of that. So our integral of sine is negative cosine. Integral of negative cosine is negative sine. And we'll go from pi over 4 to 5 pi over 4. And this is third quadrant. 5 pi over 4 is third quadrant. Cosine and sine are both negative there. So we got negative root 2 over 2. So positive root 2 over 2. And then minus negative root 2 over 2 again. So plus root 2 over 2. And then minus. And then here, this is a negative root 2 over 2 and another negative root 2 over 2. So root 2 over 2 plus root 2 over 2 plus root 2 over 2 plus root 2 over 2 ought to be 4 root 2 over 2, which ought to just be 2 root 2. Everybody good there with number 9? Cool. And then the last one somebody asked for was number 8, which we just did a couple minutes ago. So unless there are any other questions on any of those, I think that is it. Anybody have any other questions?